Sometimes we need to iterate over multiple objects of the same length, but we have to have access to elements contained in two different objects. So for instance, let's create some alteration codes list, which I will say 200, 200, and 400. So in this case, the idea is that these codes are the codes that are assigned to each one of these different types of or names of alterations. So now I want to iterate over both the name and the code of the alteration, but they are located or contained in two different objects. For that, we use the function called zip. So for instance, the format would be for name and code in, and there's no comma, in zip, and then inside the zip is where we place the objects. It could be as many objects as you want, as long as you capture the output of each one in here. So in this case, I have name first, so I'll do alterations first, and then alt codes. So what this function does, it combines the first element with the first element of this list and assign to these two. And then it goes to the second element and so on. So now to visualize the behavior of that, we can do name is code and then code. So we are going to print the result of this on the screen. So we can see that it iterates over potassic with pairing with codes 200, and then it pairs sericitic with code 300, and it pairs propylitic with code 400. We can use that in list comprehension as well. And we can not only build lists with the loop inside, we can also build dictionaries. So the format for that would be code dictionary is equals to curly braces. And then let's say we are going to use name as the key, and we're going to use the code as the value. And then I have to place the loop inside the dictionary. So I forgot the for name code in zip alterations and alteration codes. So what this does, it runs the loop inside this dictionary, creating the dictionary for each name and each code. So if I run that cell, we can see the result, which is exactly what we would expect. Sometimes we want to iterate over the elements of a data container, but also we want to have access to the index of that element. So we can achieve that using the enumerate function. So basically, if I build a loop, let's build a loop here for name and code in my newly created code dictionary. Then what I can do is print name, then is code. So this is exactly as we had before. So for any loop that you have, if you want to access the indexes, the only thing you need to do is first add a enumerate call on everything that you have on this side of this in keyword. And then for the place where you're capturing the items of the loop, we have to wrap that with parentheses and then add one more element, which is the index. And then we will have access to that index in the loop. So if I run that cell, we can see that we have access to the index now. Let's now see how to use if statements. So for instance, we can have a loop for alteration in alterations. Then for now, let's just print alteration. So we are basically looping over all the alterations. But let's say that depending on the alteration, I want to do something. So for instance, if alteration starts with, and let's say potassic. So I just need the 3 first letter because that's already unique. If alteration starts with potassic, then we can print alteration, and let's say that this is high grade. And then otherwise it will do nothing, right? So let's run this now. So only if alteration is potassic or starts with pod, we do something. So let's handle the other ones. So if we are not hitting this if statement, we can do a else and print everything else. So now we are hitting that if statement and printing that, but otherwise we're printing nothing. But let's say I want to handle each one of these individually. So I can do a elif, which stands for else if. And then I can have another test, another check. So let's say out starts with, and let's say statistic, so just SER, and then let's say in that case alteration is moderate grade. So if I run this, it handles potassic and statistic. So because I only have one more code, I don't really necessarily need to handle that specifically. I can do just a else. So if it's none of these two, then I can just say alteration is low grade. And the result of running that cell is as expected. So for each one of these cases, I am handling that with a if statement. We can use if statements when doing list comprehension as well. So for instance, if I do or alterations equals to a list, and then do for alt in alterations, this will just create the same list as alterations because I'm looping over all the items in alteration and just using the item from that loop. But if I want to restrict that, what I can do is to add a if statement. So if alt starts with prop. So in this case, I'm only selecting the proplytic, which is the low grade, but I want the or. So in order to negate this, the result of this test, what we can do is to do not. So that flips the result. So if this is not false, the result of not false is true. And if this is true, the result of not true is false. So that flips the behavior. So now if I run this, I have access to the potassic and statistic, and I'm skipping over proplytic because it doesn't match this if statement.